So I welcome you all in this first today's live session. So just let me first introduce myself. I am Sahil Gaurav, a PMRF PhD student in the specialization of power engineering at IIT Guwahati, and I am working in the control and challenge of grid forming converter in the smart transformer based low voltage distribution grid. So basically now coming to the role of mine in this course is that I am assigned as a PMRF for this course NOC 24E41 Operation and Planning of Power Distribution Systems. And the job I will do is that I will discuss the previous problems, previous assignments that have been that is somehow related to the NPTEL assignment that you have been provided. So what I want from you that just be attentive, and if you face any type of doubt related to course assignment, you can discuss with me. And when I am solving the problem, you can also interfere me if you don't understand any part or some part. And one thing I also want to mention you that at the time when I will be solving the problem, you can take your pen and paper out and solve it parallelly with me. And meanwhile, you can type your answer in the chat box when as you get the answer, right? Now coming to the content of this NPTEL course. So that will be covered by the Professor Sanjeev Ganguly. He is Associate Professor in the Department of EEE at IIT Guwahati. And in this today's session, we are going to discuss the problems related to Module 1 and Module 2, that is load characteristics and load management. And some part of Module 2, we will discuss power distribution networks, a brief overview. So before we come to today's session, I just invite you to introduce yourself one by one if you want to introduce yourself. So
Sir, very good evening, sir. Myself,
yeah,
Pradeep. Uh, I'm working with Tata Power in Odisha Discom only.
okay, okay,
I have more than 19 years experience in power distribution only and transmission distribution.
okay, nice. Any other one? Okay, Pradeep, Gokulji, and Priyadarshini, Sanjay. Okay, so let us begin today's session. So the first problem we are going to see that in this the problem says that power delivery system consists of each of the following, and the options are transmission and distribution lines, substations, distribution transformer, and D all of the above. So if anyone of you know the answer, you can type your answer in the chat box or you can speak also. So what do you think? What could be the correct answer?
It should be D.
Yeah, Pradeep. Yes, it is correct. It is D. So as we all know that this power delivery system named as the transmission and distribution system that consists of thousands of transmission and distribution lines, substation transformers and other equipments are scattered over a wide geographical area and interconnected so that it all function in concert to deliver power as needed to the utility customers. So all of the options are correct. So the correct answer is D, all of the above. Now moving to the next problem. The next problem is that which of the following customers have higher load factor? And the options are residential customer, that is domestic consumer, industrial customer, commercial customer, and D, all of the above. So what could be the correct answer for this problem? Higher load factor, as we all know that load factor is average demand divided by peak demand. So based on the consumer type, you can also guess which should have been this average demand more or less it is equivalent to peak demand. So if we see the chart, if we see the sheet, in that we can guess that this industrial customer has having higher load factor and this domestic customer has been lower load factor. So the correct answer for this problem is B, industrial customer, right?
Yes, sir.
So this one you can see the percentage is higher for industrial customer and the lowest is for domestic customer because we know that this high rate of fluctuation in the case of domestic or residential customer. But industrials they more or whatever the connected load, whatever the peak demand, they want to utilize the full rate. So that's why this is industrial customer having higher load factor. And the next problem we have that the load factor of the domestic load is it is related to the previous problem and from here from this sheet you can say that it is 10 to 25%. The lowest load factor is for domestic load. So A is the correct option. Now the coming to the fourth problem. In this problem it is asked that what is are the goal of power delivery system and the options are capability to meet peak demand, to provide reliable supply to consumers. C option is stable voltage quality and desirable power quality, and D is all of the above.
It should be
Any
D.
guess?
All of the.
Yeah,
It should be D.
yeah, very good. Yes, D is the correct option. And I have noted the important points, and that is from the lecture slides. From it has been covered. So the goals of power delivery systems are it should cover the utility service territory, reaching all consumers who wish to be connected and purchase power, and it should have sufficient capability to meet the peak demands of those energy consumers, and it also provides satisfactory continuity of service relative to the connected energy consumers, and it should have a stable voltage quality regardless of load level or condition, and it can maintain the desired power quality to the customers. So these are the goals of power delivery systems. So all the positive things that are covered in this power delivery system, that like it should cover means all, hold the service territory and capable to meet the peak demands and set and provide the reliability service and having the better voltage quality, stable voltage quality, and it should be under the uh, under this what you can say within the limits, and it can maintain the desired power quality. So the next problem is that, so now we have more theoretical type problems. In the latter part we will having numerical type problems, and in the this first session more or means many problems are based on this determining the load factor, diversity factor, and this coincidence factor, demand factor, and this loss factor. So we will solve that problem also, but these theoretical questions are very important for the basic understanding also. So this fifth number question is, which of the following is a feature of distribution system? And the options are low resistance to reactance ratio, unbalanced, transposed, lower power loss. What do you think? You can type your answer in the
This would
chat
be
box.
okay.
Yes. Now, yes, Gokul ji is replying and Pardeep are replying. Very good. So B option is correct for this problem. So resistance RYX ratio is very high in the case of distribution system. First one is incorrect. And second option is unbalanced. Yeah, it is unbalanced in nature. You can see from the table also. Distribution network are unbalanced in nature while transmission network are relatively balanced. So this is correct feature. And transpose, we know that we do transposition of line for the transmission. We do transposition in the case of transmission line, not in the distribution line. So it is also incorrect. And lower power loss, it is also incorrect because it is having high RYX ratio. That's why it occurs more higher power loss. So can anyone tell why we do transposition in the case of transmission line? Just I want to make little bit interactive this session. So our transmission networks are basically that are because we are having various uh, based on the poles and towers. These are having irregular, if we don't do transposition they may occurs unbalanced voltage drop across the lines. We are doing the transposition of transmission line so that we get the balanced voltage profile at the end of transmission line. Otherwise due to like different heights and towers and different slopes, so this leads to different voltage drop across the line. That's why to having a symmetric voltage across drop across the line across each phase, we do the transposition of lines at a by dividing the distance of transmission lines. So we do transposition so that we get balanced voltage profile, but this thing we cannot do in distribution network. Now coming to the next part, that is question number 6. You have to choose the correct statement. It is also related to the previous problem. The first option is distribution networks are usually operated as radial. B option is distribution networks are usually unbalanced as compared to transmission networks. C option is distribution networks are usually suffer from more faults as compared to transmission networks. And D option is all of these.
All of these, D option.
Yeah, is correct. So distribution networks are usually operated as radial. They are radial in nature. So first is correct one. And distribution networks are usually unbalanced as comparison to transmission networks. And the distribution networks are usually suffer for more faults as compared to the transmission networks. We can see from the table fault occurrence in distribution network is higher. So all three above are correct. So D is the correct option. All of these. So distribution network is radial nature. You have to keep in mind these are unbalanced, non-transposed, and power losses is higher due to high R/X ratio. Now the next problem is that which of the following is our distribution substation equipment? And the options are A circuit breaker, B isolator, C impedance relay, and D is the distribution transformer. So here I want to mention that it is multiple select question. More than one options are correct. I will tell you which question is like single choice or multiple choice question. Multiple select problem. So here more than one options can be correct. So you can type your answer in the chat box. What do you think? Which of the following are the distribution substation equipment? Circuit breaker, isolator, impedance relay, distribution transformer. Pradeep is saying B and D. Okay. And Rahul Patil is saying ABD. So circuit breaker is necessary. So this one is correct. First option is correct. Isolators are also necessary. Impedance relay is not should be the part of this distribution substation because it is the in the transmission level. So impedance relay is not part of distribution substation equipment. Now the question is that does this distribution transformer comes under distribution substation equipment? So this is also not part of distribution substation equipment, distribution transformer. So why is it so? Can anyone tell?
I think distribution transformer is also one of the equipment used in distribution system for auxiliary power supply purpose.
Okay, oh, in substation.
Yes, yes.
Yeah,
How we can get supply in the distribution substation with the help of distribution transformer?
yeah. So that's why I'm pondering over here. But the correct answers are that given by this course means NPTL, that circuit breaker and isolator. Distribution transformer at the end of customers where we are providing the secondary distribution system. So it is not part of distribution substation, but you are correct. There many things are present by
I think,
we can
sir,
say.
I think in distribution system generally we use the nomenclature as a station transformer, but which is also one of the distribution transformer rating below 100 kVA. So it may be a distribution transformer, I think.
I think this is correct for circuit breaker distribution transformer, which cannot consider this is station transformer, but distribution transformer is some different, which is used in 11 kV and zero point 0.4. I think circuit breaker isolated is correct answer.
Yeah, yeah. Distribution transformer we are using for the individual customers, not for the
Yes, yes.
auxiliary supply. That is the correct option. That is the means best answer for this problem. Is correct. Thank you. Yeah. Now moving to the next problem. So what is hierarchy of power delivery system? So the options are here. Means you have to go from the top and bottom, and the options are like C, A, B, C, D, and it is just mingled with each other. So you have to tell the correct answer. So what we should be the hierarchy of power delivery system?
Is the correct answer.
Yes.
B is the correct answer.
Yeah. Yeah.
I think.
Correct. Correct. So B is the correct option. Transmission system, sub-transmission system. Then we have primary distribution system and secondary distribution system. And I have noted the important points about this hierarchical system. First, we are having transmission system that connects from the generating power plants to the means load centers, and then we are having a that provides a strong electrical type in generators so that they can be synchronized with the system and the generators. And the operating voltage range is 69 kV to 1100 kV and have capacities between 50 and 2000 megawatt. And now BBC sub transmission system that is to take power from the transmission stations to or generating plants to deliver to distribution substations, and it is of reduced capacity than transmission system and voltage levels. And someone mic is turned on, could you please turn it off, because this session is being recorded, so it will recording will not cover means not will clear. At that when you want to speak, just turn off your mic. So sub transmission system having operating voltage range from 35 4.5 kV to as high as 230 kV, and the primary distribution systems that is to carry power from the substation to the distribution transformer, and its operating voltage range is 2.2 kV and to 34.5 kV, and the capacity is between 2 and 35 megawatt. And secondary distribution system that used to supply power to the individual customers and usually operated a voltage of 1100 sorry 110 to 120 voltage single phase or 220 to 230 volt single phase. I have also you can also refer this diagram. From there you can see this transmission system, and this is generating power plant. Then we are having substation, switching substation, then sub transmission system comes, and then we are having distribution substation, and then this is primary distribution system that is represented here feeder, and then it connects to the secondary, it connects to the distribution transformer where we are having the secondary distribution network, secondary distribution system. So this is the one of the very nice picture that demonstrates about from the higher level to lower level. So the next part is that in this problem, the starting point of primary distribution network is substation, distribution transformer, generating station, and secondary distribution network. You can type your answer in the chat box. I am represented one figure also here for your reference. You can take the help from this figure also. Yeah, Manish, Rahul, Pradeep. Yeah, Manish is typing A. Yes, A option is correct. We are having substation first, then this primary distribution network, and then this is connected. This connects between substation to distribution transformer, and then we are having secondary distribution network that connects distribution transformers to individual customers. And generally in India, this primary distribution network having voltage ranges of 11 kV or 33 kV, and this secondary distribution network having voltage range is 400 volt, that is line to line voltage, and if you convert into phase voltage, that it comes to 230 volt. Now the second, it is related to the previous problem, and the problem said that the end point of a primary distribution network is, and the options are substation, distribution transformer, generating station, residential consumer loads. Yeah, B. Yes, correct. B is the correct option. Primary distribution network connects from the substation to the distribution transformer. So B is the correct option. Now 11th number problem is that the utility voltage implies to, and the options are sub transmission level voltage, distribution level voltage, voltage at which load consumes power, and D option is all of these. So what could be the answer? Rahul, Manish, Pradeep. Rahul and Manish are saying D and Pradeep is saying C. Okay. So the utility level voltage, that means the voltage level at which we are taking the power, at which the consumer is taking power. So the C option is correct. It is not distribution level voltage. Distribution level voltage may be 11 kV, 33 kV, but we are at household we are getting 400, we are getting 400 volt line to line voltage. So that is the voltage at which load consume powers, and some loads may be like industrial loads may.
Excuse me, sir.
Yes, yes, tell me.
Sir, it means actually utility voltage is consumer's voltage level.
Yes, yes. Utility means
Okay, sir.
what?
Thank you, sir.
Utility means what? We are the consumer voltage.
Ye-
It,
Yes, sorry, sir. I didn't see utility. I only see voltage imply. Sorry, sir. Thank you, sir.
yes, sure. Now, now coming to the next problem. The next problem is that the maximum demand on a power system is 100 megawatt. If the annual load factor is 40%, calculate the total energy generated in a year. So these now you have to take your pen and paper out. And now you have to solve the problems, numerical type problems. So I will solve here also, and in parallel with me you solve. If you get answer before me, then you type your answer in the chat box. So one important expression is that load factor, that is average demand divided by the peak demand. So the maximum demand on power system is given, that is peak demand is given, and the annual load factor is given as 40%. So the calculate the total generated in a year. So we can convert this into energy, like these are given in power, so we can write annual load factor equal to total annual energy divided by annual peak demand into number of hours. That is, if you calculate the number of hours in a year, then it will come as number of hours in a year, then it come as 365 into 24 8760 hour. So now annual load factor is given as 40%, so it is 0.4 total annual energy we have to calculate. So it will be annual peak demand is 100 megawatt. So 100 megawatt into 10 to the power 6, and number of hours is 8760. So this will give you total annual energy equal to 350,400 into 10 to the power 6. So you can write it as 3504 into 10 to the power 5 kilowatt hour. So the correct option for this problem is B. So these are very simple problem. I think all of you get it. Yes, Pardeep is correct. Rahul is correct. B option is correct. Now coming to the next problem. If you face any problem or doubt, then you can ask me. So the next problem is that a residential customer consumes maximum of 2 kilowatt for 7 hours, 500 watt for 8 hours, and 800 watt for the rest of the day. The load factor for this load is, and the options are 0.525, 0.625, 1.425, 0.785. So we will apply the previous expression only, the load factor. First, for the load factor, we will calculate the average demand. Average demand equal to unit number of units consumed divided by number of hours. So unit consumed we can calculate for first 7 hours, it is 2 kilowatt, then 2 into 7, and then 500 watt, that means 0.5 kilowatt for 8 hours, and 800 watt, that is 0.8 for the rest of day. So that means 8 7 15, and 15, if you subtract 15 from 24, that will be 9. So and the number of hours in a day is 24. So we will get average demand is 25.2, and peak demand we can see from this. So 2 kilowatt 500 watt and 800 watt. So peak demand is 2 kilowatt. Sorry, it is 2500, 25.2 kilowatt hour divided by 24 hour. So therefore load factor will be 25.2 divided by 2 into 24, that will give you 0.525. So correct option is A. Yes, Rahul is correct. Rahul Patil, very good. Dharmender, Gokul, Gopi Krishna. So moving to the next problem. So the next problem is also based on the load factor only. So in this problem, it is asked that a distribution feeder consumes 120 units of energy in a day and peak load on feeder is 10 kilowatt. Determine the daily load factor of the feeder. So I am asking one question here. So what do you mean by this 1 units of energy? So if anyone is saying 1 unit of energy, that means what could be the quantity?
120 watt.
1 kilowatt hour.
Yeah, 1 kilowatt hour. And this,
1 kilowatt hour energy.
yes, correct. So in household also we are getting the electricity bill based on this, this only that they say about how many units energy you have consumed. So 1 unit of energy means 1 kilowatt hour. So here it is saying that 120 units of energy. So it will be 120 kilowatt hour. So now we have to find the daily load factor. Daily load consumed, daily load, daily energy consumed, that is better to write. Energy consumed divided by peak load, peak demand, peak demand into 24. This is hour. So daily energy consumed is 120 kilowatt hour and peak demand is given as 10 kilowatt. So this will give you 0.5. So correct option is 0.5 A. Now one simple problem here is that the AC secondary distribution system is generally off and the options are 3 phase 3 bias, 3 phase 4 bias, 1 phase 2 bias, 2 phases 2 bias. You can type your answer in chat box. So this will what should be the correct answer? 3 phase 4 bias. We are having neutral point. So this is 3 phase 4 wires. Now the next question is that some question I have solved previously, so they no need to just you see what are the things. So in this problem it is asking about the radial distribution feeder of 35 nodes consist of, and the options are 35 distribution lines, 36 distribution lines, 34 distribution lines, 33 distribution lines. So in the radial distribution systems, whatever the number of nodes, that it will be equal to the number of lines plus one, because the number of here if you see this, if you represent this one as node, then number of lines will always one lesser than the number of nodes. So it is very simple. If suppose in a distribution radial distribution system having three nodes, then this consists of two lines, just like that. So here you can write, here you can see that 35 is the number of nodes, therefore number of lines will be 34. So C option is correct. 34 distribution lines. Now the next problem is that the power demand of the flowing load is proportional to a square of voltage. And the options are electrical motors, welding machines, water heaters, and D is all of these. So which option is correct? Depending upon the type of loads, we are having three types of load: constant power load, constant current load, constant impedance load.
Water heater.
Okay. So from here you can see that I have mentioned here a square of voltage. That means this comes under constant impedance load. So the constant impedance example are incandescent like and resistive water heaters. So C option is correct. Now the next problem is that which value of load factor is preferable to utilities? Options are near to unity, near to 0, near to zero point 0.5, near to 0.25. What do you think?
Near to unity.
Near to unity, sir.
Yes, yes, correct. So correct option is near to unity. And the reason behind this is that I have mentioned in the points here. This load factors plays key role in determining overall cost per unit generated. So higher the lower factor of power station, that means lesser will be the cost per unit generated. And vice versa, a lower load factor means high maximum demand and low utilization rate. So if the load factor is very low as high peak demand, the capacity of electrical energy remains inactive for a longer time, and this will increase the per unit cost of the electrical energy to the consumer. To reduce the peak demand, this we have to sim some load from the peak time to non-peak time, so that is improves the load factor. That means we are reducing the peak load demand, and it will also reduce the average cost per unit. And we know that we will see this what this procedure is called. But the main reason is that we want to improve the load factor, so that we are having uh, lesser will be the cost per unit generated. Now the next problem is that, so it is similar to the previous type problem we have solved. In this problem it is asked about that there is a lighting load which is operating from 6 p.m. to 6 a.m. daily at constant demand of 100 kilowatt. The load demand for the rest of the time is zero. The load factor for this load is, so it is 6 p.m. to 6 a.m. and it is having constant demand. So for 12 hours it is, we have to 100 into 12, that is unit consume, that is the energy consumed. So for finding average demand you have to divide by 24, so you will get average demand, and peak demand is 100 kilowatt only. So therefore load factor is 0.5. C option is correct. Now moving to the next problem. This problem is also a little bit important. You have to choose the correct sentence. So the area under a load curve is greater than that of load duration curve, and B option is area under load curve is lower than that of load duration curve. C option is that it is equal to the load duration curve, and D option is that it is half of that of load duration curve. So what is the correct answer? So load curve and the area of load duration curve, it is equal, because this will give you the energy consumption. So this, whatever, if you make the load curve load duration, the difference between the load curve and load duration curve is that means load duration curve is just rearranged in another way. And how it is rearranged? It is rearranged in that way based on the descending order of load magnitude. So the area will be remain same as it is. So the correct option for this problem is it is equal. C option is correct. Okay, we can solve one or more two problems. So the next problem, moving towards 21. In this problem, a residential customer consumes 1 kilowatt for 2 hours, 750 watt for 8 hours, and 300 watt for rest of the day. You have to find the load factor for this load. So first you have to find this average demand. So average demand will be number of units consumed divided by number of hours. It's because it is load, so it is better to write consumption. So number of units consumed divided by number of hours. So yeah, 1 kilowatt for 2 hours, then 0.75 kilowatt for 8 hours, and 0.3 for rest of the day. That means 8 plus 10, 8 plus 2, 10, and 24 minus 10 will be give you 14, and that will be the number of, that will be the energy consumption. It should be divided by 4 to get the value in power. So you will get the value in power as 0.508 kilowatt. And if you see the if you see the load behavior, then it is consuming 1 kilowatt for 2 hours. So that is peak demand. So you can calculate load factor as 0.508. A option is correct. So I think our call, actually what is happening, I am out of India, so that's why we cannot do one Google Meet for more than 1 hour. So I am sending you, all of you, one link. All of you please join this, all of you please join this link, and we will end this session and we will meet there. Are you getting this link?
Yes, sir.
Sure.
Yes, sir. Okay.
So I am ending this session, and you can join this meet through whatever I have given in the chat box.
तो उसमें यूपीएससी की अच्छी एसएससी क्या?
Manish, please turn off your mic. Okay, all right. Now I think everyone came, so now I am ending this session. Are you able to see the screen?
Yeah.
Yes, sir.
Nice, sir. But
Yeah, fine, good. So moving to the next problem, we will see some problem like the newer problem. We are now whatever the similar type problem I have already solved. We will see some newer problem so that I will solve parallelly with you. Here just you have to see that what are the ways we have to solve. So in this problem, that is problem number 22, it is asked that a distribution feeder having four residential customers and the peak load demands of these customers are given as 25 kilowatt, 75 kilowatt, 150 kilowatt and 100 kilowatt and 50 kilowatt. Total connected load of these customers is 1000 kilowatt. The coincidence factor of this load is zero point 0.7 and there are three questions based on this statement. So first part is determine the peak demand of the feeder. So how we are going to find the peak demand of the feeder? That is group peak demand because it is having five residential customer. So here this coincidence factor is given. So from the coincidence factor we can find the diversity factor. Coincidence factor is just the reciprocal of diversity factor, and we know that diversity factor is sum of individual group peak demand divided by the group peak demand. Sum of individual peak demand divided by the group peak demand, that is diversity factor, and here coincidence factor is given as 0.7. This is given as the coincidence factor of these loads is given as zero point 0.7. That means coincidence factor of the feeder is given as zero point 0.7. So you get the diversity factor, and diversity factor is the ratio of individual peak demand divided by the group peak demand. So sum of individual peak demand is 25 plus 75 plus 150 plus 100 plus 50, and we can find from here the group peak demand. So the group peak demand will become as 402.7 is equal to 400 multiplied with zero point 0.7, that will give you 280 kilowatt. So the peak demand of the feeder is 280 kilowatt. So this is really nice problem. Then how you can find the peak demand of the feeder with the help of coincidence factor if the individual peak demand is given. So this is really one of the good problem. Now in the second part, you have to calculate the demand factor of the feeder. So demand factor is nothing but it is reciprocal of maximum demand. Sorry, it is the ratio of maximum demand to the total connected load. So we have calculated in the previous part the maximum demand, that is peak demand. The maximum demand is 280 kilowatt and total connected load is also given. So total connected load of these customers is given as 1000 kilowatt. So from there you can calculate the demand factor. So it is coming at 0.28. Now the load diversity. So load diversity is sum of individual peak demand minus group peak demand. Sum of individual peak demand is like 25 plus 75 plus 150 plus 100 plus 50, and group demand we have calculated in first part. Group demand is 280 kilowatt. So 25 plus 25 100, and then 200, this is 300 plus 100, that will be 400. So 400 is the sum of individual peak demand. So here you can write one point also if you want to write. Load diversity is sum of individual peak demand minus group peak demand. There are many names of group peak demand. Somewhere you can see aggregate peak demand, somewhere you can see coincidence peak demand. So that is all same. Group peak demand you can say, or you can say aggregate peak demand, you can say coincidence peak demand, that all are same. Don't confuse with this.
So this group peak demand means any individual.
No, that is the peak demand of feeder. Means like here if you see this feeder having consist of five customers. So they have given the individual peak demand, right? So means it is not necessary that whenever the peak demand is happening for, like here if you see this third number customer having higher value of peak demand. So this is not necessary that this is the, like this is not will be the peak demand for the feeder. So this is individual peak demand. So you have to find the peak demand of feeder with the help of data. So here data is given as coincidence factor. So from the coincidence factor you can find the group peak demand. Group peak demand means like the feeder, because from the feeder all the power is coming, and it is having several customers. So it is individual peak demand is given like for different duration of time, and because at certain duration of time it is in like many customers are having taking power. So how you can find the peak demand for the feeder? So based on this,
So this is for calculation. Yeah, and practically this is maximum the P max feeder. This is 280 kilowatt. Yeah, it may come. It may increase 300, 350. It may happen practically.
okay, practically, how means practically I don't means I have to see, but
Okay.
based on this data you can say that this will be the
Okay. So
maximum
if
demand
you
of.
change this coincidence factor, that can be increased. Okay, sir.
Yeah, sure. If you want to means because you are industry person, you have may some practical experience, so you can have some knowledge then share with us. That is also great for all of you, but these are things that helpful in your assignment problem and you in your NPTEL exam. So
Right.
don't apply any other thing, because these things are that will be uh, that will be taken care.
Okay. Okay, sir. Thank
Yeah.
you.
So yeah, so load diversity, we have you have to just remember the expression load diversity is sum of individual peak demand minus group peak demand. So it is 120 kilowatt. Now the you have to find the diversity factor of the feeder. So diversity factor is nothing but it is reciprocal of coincidence factor. So it is 1 divided by zero point 0.7. So it will come as 1.43. So 120 kilowatt is the correct option for third part, and for last part it is 1.43. Now the next problem is that a radial distribution feeder of 10 nodes, and the total average daily energy consumption of the feeder is 5000 kilowatt hour. The daily load factor of the feeder is 0.75. Determine the daily load peak demand of the feeder. So we have solved many problems on load factor, so there is nothing new. So here we are having daily energy consumption is given as 5000 kilowatt hour. So average demand we can find like this: 5000 kilowatt hour divided by 24 hour, that will give average demand, that will give power value, and load factor is given as 0.75. So you can find the daily peak load demand. So peak demand will be coming as 277.78 kilowatt. A option is correct. Now moving to the next problem. So this problem is also having sub part. I just want to say that uh, some question may be look lengthier, but whatever things is that you have to apply only the expression that is load factor, demand factor, diversity factor, coincidence factor, loss factor. All these expressions um, just you have to assemble. I will also take one revision session at the end where where I will put all the expression so that you can get one summary. But don't afraid of the lengthy problems. Just 1 second, guys. I am taking a pause for 1 minute. Sorry for interference. So now we are here. So here there are two residential customers. Both the customers have air conditioning systems of identical rating of 2 kilowatt, and the customer one uses it daily from 9 p.m. to 5 a.m. The customer two uses it daily from 2 a.m. to 8 a.m. The daily energy consumption of customer one due to the air conditioning system is 12 kilowatt hour. The daily consumption of customer two due to the air conditioning system is 10 kilowatt hour. Assume that both the customers don't have any other loads. Assuming the daily load factor of the air conditioning system of the customer is zero point 0.4, you have to determine the peak demand air conditioning system of customer one. So it is so you have to go a step by step. Here the first part is that you have to find the peak demand. So the load factor of customer one is given as zero point 0.4, and the average demand we can find from here. You can see this daily energy consumption of the customer one due to the air conditioning system is 12 kilowatt hour. So the average demand you can find 12 kilowatt hour divided by 24 hour. So you will get zero point 0.5. From there you get peak demand that is coming as 1.25 kilowatt. So there is nothing new in this problem. Now the second part of problem is that assuming the daily load factor of the air conditioning system of customer 2 is zero point 0.5, determine the peak demand of the air conditioning system of the customer 2. So here they have given the load factor of customer 2.5. It is similar to the previous problem. So average demand we can find from the energy consumption. So the energy consumption is given as for the second customer is 10 kilowatt hour. Here you can see. So 10 kilowatt hour divided by 24 hour, that will give you average demand. So from there you can find the peak demand. So you will get peak demand as 0.833 kilowatt. So B option is correct. Now the third part is that if the diversity factor of the load is 1.5, determine the group peak demand due to the air conditioning of both customers. So here diversity factor, we know that sum of individual peak demand divided by the group peak demand. So diversity factor is 1.5. So sum of individual demand be sum of individual peak demand we know that is 1.25 kilowatt and 0.83. Yeah, sum of individual peak demand we have found in the previous two subpart. So 1.25 plus 0.833 kilowatt. So from there you can find the group peak demand of both the customers. That will come as 1.39 kilowatt. Now coming to the last part of this problem. If the contribution factor of the customer 1 is zero point 0.5, determine the contribution factor for customer 2. So we know one relation is that this contribution factor and the individual peak demand and the group peak demand is that aggregated group peak demand is equal to the contribution factor of individual into the peak demand for that individual plus so on. Means whatever the number of the customers you have to just add up there. So group peak demand we have calculated 1.39 kilowatt, and this contribution factor of customer 1 is zero point 0.5. So the P1 individual peak demand is 1.25 kilowatt, and we have to find the custom contribution factor of C2, contribution factor of customer 2, that is C2. So C2 we have to find, and this individual peak demand for customer 2 is 0.833. Therefore, you have to do simplification. You will get the answer as 0.92. B option is correct. Now then, one problem, question number 25. This problem is based on this loss factor. So we have to also remember this expression. Loss factor is average power loss divided by power loss at peak load demand. And here in this problem, this distribution feeder incurs 5000 kilowatt energy loss daily. This energy loss is given, and energy loss during peak hour is 1000 kilowatt hour, and the peak demand time is also given, that sustains for half an hour. So you have to determine its loss factor. So average power loss, how you can determine this average, this energy loss is given, so 5000 kilowatt hour divided by number of hour, 24 hour, so it will give you 208.33 kilowatt, 208.33 kilowatt. And this we have to find the power loss at peak load demand, so it is 1000 kilowatt hour, and this number of hour is zero point 0.5 hour, so it will give you 2000 kilowatt. Just put both the values in this loss factor expression, you will get 0.104. So A is the correct option. Now moving to the next problem. So here in this problem 26, a generating station has a maximum demand of 80 megawatt and a connected load of 150 megawatt. If the megawatt hour generated in a year is 400 cross 10 to the power 3, calculate load factor. So just look into the data, and what are the data you have given, simplify this to get the average load. So maximum demand is given as 80 megawatt, connected load is 150 megawatt, units generated in a year is 400 into 10 to the power megawatt hour. We know the total number of hours in a year is 8760 hours, so average load will be 4000 into 10 to the power 3 divided by 8760, that will give you 45.662 megawatt. And we know that load factor is average demand divided by peak demand, so it will get 0.57 as answer. Now for the demand factor is the ratio of maximum demand divided by total connected load. Maximum demand is given as 80 megawatt, and total connected load is also given, so demand factor is quite easy to calculate. Both values are given directly, but for the load factor generally they give the values in the terms of energy consumption or energy demand. So just calculate in the terms of power and then get the load factor value. So demand factor you will get 0.533. Now the next problem. Here in this problem, a sample distribution system is shown in figure. One of the feeders supplies an industrial load with a peak of 2 megawatt. Another supplies in the residential load with a peak of 2 megawatt. So one is industrial load. This having peak demand of 2 megawatt, and residential load with having peak demand of 2 megawatt. Combined peak demand is 3 megawatt. You have to determine the diversity factor. So it is quite easy. We know that diversity factor is the ratio of sum of individual peak demand divided by the group peak demand. So individual peak demand is 2 plus 2 4 megawatt, and group peak demand is 3 megawatt. So group peak demand is 3 megawatt. So you will get diversity factor as 1.33. Now load diversity is the subtraction of individual peak demand to the group peak demand. So individual peak demand is 2 plus 2 4 and group peak demand is 3. So the load diversity is 1 megawatt. And coincidence factor of the load connected to the transformer. So we know that coincidence factor is the reciprocal of diversity factor. We have calculated the diversity factor. So it will be coming as 0.75. Now this question number 28. In this problem, a substation supplies power to 4 feeders. So feeder A has 6 consumers whose individual daily maximum demands are 70 kilowatt, 90 kilowatt, 20 kilowatt, 50, 10 and 20 kilowatt, while maximum demand on the feeder is 200 kilowatt. So feeder A having maximum has 6 consumers and whose individual maximum demands are given, and the feeder A having maximum demand of 200 kilowatt, and feeder B supplies 4 consumers whose daily maximum demands are given as this, and maximum demand of feeder B is 160 kilowatt, while feeder C and D have a daily maximum demand of 150 kilowatt and 200 kilowatt respectively, while the maximum demand on the station itself is 600 kilowatt. So it is like hierarchical type problem. You have substation, then it is having 4 feeders, feeder A, feeder B, feeder C and feeder D, and each individual feeder having their respective customers and their respective consumers. Why here it is given that feeder A having 6 consumers, so it is having 6 consumers, and while feeder B having 4 consumers, and feeder C having this maximum demand only given, they have not told about this number of consumers, while the maximum demand of the substation is given. Like for this maximum demand of substation is given separately, and for the maximum demand of each feeder is given separately. And for consumer also maximum demand will different. So this problem have a good idea about the diversity factor, constants factor, and how this individual demand is different and group peak demand is different. So the first problem is that diversity factor of for feeder A. For feeder A, you have we know the diversity factor is sum of individual maximum demand divided by group peak demand. So feeder A having 6 consumers and all the peak demands are given. So 70 plus 90 plus 20 plus 50 plus 10 plus 20, and this feeder A having maximum demand is also given, that is group peak demand. So it will divide by 200 kilowatt. So it will give you answer 1.3. If you having any doubt, you can ask. Now moving to the for feeder B. So similarly for feeder B it is given maximum demands for consumers 60 plus 40 plus 70 plus 30, and this feeder B maximum demand is 160 kilowatt. So just you have to divide by 160 kilowatt, you will get the diversity factor for feeder B. Now for the diversity factor for the substation. For the substation, you have to, like here you have to treat this feeder as the individual maximum demand. So you have to find the individual maximum demand for feeder A, feeder B, feeder C, feeder D. So all these values are given. For feeder A maximum demand is 200, for feeder B it is 160, for feeder C 150, and for feeder D 200. And substation maximum demand is 600 kilowatt. So you will divide, you will get 1.183 as the answer. Now we will solve some problems. Till here I have solved all this problem. Now we will solve parallelly, and you when you get the answer you can tell me. And we are left with 10 question more, that will be final. So whatever we understood, just we will apply here. So here common data for question 29 to 35. So here this distribution feeder having 5 customers with individual daily peak load demand of with daily peak demand of 3 kilowatt, 5 kilowatt, 2 kilowatt, 7 kilowatt, and 9 kilowatt. And the corresponding contribution factor of each load is 0.15, 0.20, 0.2, and zero point 0.4 respectively. Total connected load of this customer is 50 kilowatt. You have to find the peak load demand of the feeder. So peak load demand of the feeder be having this contribution factor given and this individual peak demand is given, so we can find the peak load demand of we know that one relation where we are having relation between the contribution factor, individual peak demand, and the group peak demand. When you are getting answer, you can type your answer in chat box. Peak load demand of the feeder will be. So P feeder max is equal to C1, the contribution factor from the single individual. From customer 1, we can write C1 into P1 max, con contribution factor of second customer, and individual peak demand of that customer, and C3 into P3 max, maximum demand of customer 3, C4 into P4 max plus C5 P5 max. So put all these values. P feeder max. So we are solving the problems for the assignment 1 and assignment 2 both. So if you batch this session and if you means look into the session and problems, then you are able to solve the assignment 1 assignment 2 very easily. 0.15 into 3, C2 into P2 max is 0.2 into 5 kilowatt, and C3 is 0, P3 max is 2 kilowatt, C4 is 0.2, P4 max is 7 kilowatt, C5 is 0.4, P5 max is 9 kilowatt. So put all these values, 0.45 plus 1 plus 0 plus 1.4 plus 3.6, you will get 6.45 kilowatt. So B option is correct. Sorry, B not C option is correct. So options are little bit confusing. So good, many of you are present because after 1 hour it's very hard to put you attention, means even for us also. C, yes, Rahul Patil, very good. So more, we have 40 minutes more, but we will try to cover within 20 minutes. 6.4 kilowatt. Now, next problem. Here you have to find the demand factor. Can anyone tell what is the expression of demand factor? So that you just keep yourself attentive. Anyone tell demand factor expression?
Max maximum demand by connected load, total connected load.
Maximum demand, yes, very good. Maximum demand divided by total connected load.
Total connected load.
Yes. So maximum demand of the feeder we have, because it is asking about demand factor of the feeder, so you have to put the maximum demand for the feeder. So maximum demand for the feeder we have calculated in the last part, that is 6.45 kilowatt, and total connected load of this customer is 50 kilowatt. So you have to divide it with 40 kilowatt, sorry 50 kilowatt, you will get 0.129. So B option is correct. Yes, Pradeep Das Adhikari, correct. B option is correct. Now next part, question number 31. Here we have to calculate the load diversity factor. Again, someone please try yours. Someone please tell the expression of load diversity factor so that you can also remember.
S- Sum of individual maximum demand
Yes,
minus
Divided by maximum demand of the group.
yes, correct. Very nice. Yeah, means load diversity factor, and one expression I also wrote. I think from that you confused. That is load diversity. So factor and load diversity is quite different.
sum of individual maximum demand minus group peak demand.
No, no, it is asking about factor. I'm not asking is only load diversity. So just take care.
Sum of
Okay, okay, okay,
individual
okay.
demand divided by the group peak demand
Sum of individual peak demand,
divided by group peak demand.
group peak demand. So load diversity factor is sum of individual peak demand, that is 3 plus 5 plus 2 plus 7 plus 9, and group peak demand we have calculated in the first part, that is 6.45. So we will get 26 divided by 6.45, 4.031. C option is correct. And I think you are confusing with this one. So I also want to write here load diversity is different. Load diversity is be represented with PLD, and this sum of individual peak demand minus group peak demand. So that is lesson. If we are asking about factor, then take the ratio. It is asking about the value, then you have to subtract group peak demand. Now next problem is that you have to find the coincidence factor of the feeder. So coincidence factor, it is quite easy. We have coincidence factor is nothing but it is the ratio of diversity factor. It is the ratio of diversity factor. So 1 divided by dVf, and diversity factor we have calculated, that is 4.031. So it will give you 0.248. So correct answer is D. Yes, Rahul Patil, C. So for the previous part it is C. Correct. Now the next part is, if the feeder consumes 100 units of energy in a day, determine the daily load factor for the feeder. So 100 units of energy means 100 units of energy means 100 kilowatt hour. And daily load factor we can write, that is daily load energy, energy consumption, daily load energy consumed divided by peak demand into 24. So daily energy consumed is 100 kilowatt hour and peak demand is peak demand we have peak demand we have calculated in the previous part, that is group peak demand. That is coming as 6.45 kilowatt. In question number 29 we have calculated. So 6.45 kilowatt and number of hour is 24 hour. So we will get 0.6459 approximately equal to 0.646. So A is correct one. Now so how many of you got this answer? I think very less people right now solving. Yes, Rahul is solving. Yes, good. A is correct. 0.646. Now the next problem is that if there is 8% daily loss of energy in the feeder due to the line ohmic loss, determine the power loss during peak demand hour assuming the loss factor as 0.5. So for loss factor also we have to calculate the average power loss. So average, first we are going to calculate this average load. Units consumed divided by time in hour. Time in hours, so it is 100 kilowatt hour divided by 24 hour. So it will give you 4.167 kilowatt. So average power loss is 8% loss of energy. So you can calculate average power loss from the average load. Average power loss is 8%. So 0.08 into 4.167 kilowatt. That will give you 0.33 kilowatt. So in this question you have to find the power loss at peak demand. So you have to remember this loss factor expression. Loss factor expression is average power loss divided by power loss at peak load. Power loss at peak load. So remember this expression. It is related with load factor only. So if you remember load factor, then loss factor you also remember with respect to that. Average power loss factor is given. Loss factor is given as 0 0.5 and average power loss is given as 0.33. So you have to find this power loss at peak load. So power loss at peak load will be 0.667 kilowatt, approximately equal to 0.67 kilowatt. Sorry, It is sorry, it is ratio 0.67. So B option is correct. Yes, Rahul, you are correct. Rahul Patil. Now the last part of this problem, question number 35, last part for this common data problem. In this problem, if the peak load demand sustains for half an hour, so the peak load duration is given half an hour, determine the energy loss during the peak demand hour. So it is very simple. So we have found power loss at peak load, power loss at peak load. We have found that 0.67 kilowatt, and this number of hour is given is zero point 0.5. So what will be the correct answer for this problem? Anyone can tell? Energy loss during peak demand hour will be during peak demand hour will be, what should be the correct? What should be the answer? Yeah, Rahul Patil, you are correct. 0.67 into zero point 0.5. So it will give you 0.34 kilowatt hour. So 0.34 kilowatt hour. Here should option will be more. Means unit should also be given. A option is correct. Now this last problem, question number 36 to 38, and that is really important. In this problem also, the last part is more important, question number 38, because that has not been covered in the regular class, means NPTEL online class. So you have to look into this problem very carefully. So here there are three different types of customer connected to feeder: lighting load, commercial load, residential load. And the load demand for a typical day is shown here. Means for a one day, like for each hour it is given what is the load demand for different type of load. And the total connected load for lighting load is, the connected load for lightning load is given 150 kilowatt, and for commercial and residential is given as 1600 kilowatt and 2250 kilowatt respectively. So these are data, these are tables, and the first part you have to find the load factor for lightning load. So load factor for lightning load, it is average demand, it is the ratio of average demand divided by the peak demand. So you can find, first you have to find unit consumption during 24 hours. So it is quite bit little bit take care, means each and every part, but options are given. If your answer is not coming to matching with answer, you can look into your calculation. For average demand, you have to first find the energy consumptions. Like here, uh, I have done in this way, like 50, how many times it is coming? 1, 2, 3, 4, 5, 6, 7. 7 times 50 is coming, so 15 to 7 hour. And then 0 is coming for 0 is coming 11 number of times. And again 50 is coming, so 15 to 1. And again 100 is coming, 100 to 1. And again 150 is coming, so 150 to 4. So that is number of units consumption. So if you do simplification, then it will be give you 1100 kilowatt hour. So average demand will be divided by time in hours, so it will give you 45.883 kilowatt. Now for this peak demand for lightning load, you have to see what is the peak demand for lightning load. It is 150 kilowatt. If you see the table, so load factor you can calculate in this way. So correct answer is 0.3055. So this is means just you have to take care of the table and solve very carefully. Now, because this type of problem is given in your assignment too, so you have to do like similar way. Here I have taken a longer table, but in this assignment too, I think it is little bit not that much lengthier. Here this table becomes lengthy because the data is given for each hour. So 24 number of rows is available here. In in question number 37, you have to find the demand factor for residential load. So demand factor, all data are given. We know the demand factor is ratio of maximum demand to the total connected load. Maximum demand is 1200 kilowatt. Total connected load is also given 2250 kilowatt. So demand factor you can find as 0.533. Now coming to the last problem, that is very important because this part is not discussed in class. So here from the table you have to find the contribution factor for commercial load, right? And we know that group peak demand is related with individual demand by this coincidence factor, by this contribution factor. So I have written down this group peak demand is equal to contribution factor from lightning load, and the maximum lightning load is here, and this contribution factor from second type is commercial load, and then maximum demand for commercial load, and then this C residential is contribution factor from residential load and maximum demand from residential load. So here I have written down more in a good way that here it is PGR mix, that is group peak demand, and it is also called as aggregate peak demand. It is also called as coincidence peak demand, and these are the non-coincidence peak demand, means they are individual peak demand. So here in this problem you have to find the commercial load, contribution factor of commercial load. So here in this we can see that this PGR max is known, this P light max is known, this P commercial max is known, this P residential max is known, but contribution factor for lightning load, commercial load, residential load, all three are unknowns. Then you cannot find with this expression, right? We cannot find this with the expression from the table. Then what is the other way? So other way is that you have to remember this other expression. This class contribution factor is that class demand at time of system peak divided by class non-coincidence maximum demand. Now first you have to find the system peak demand, that is group peak demand. Means for finding peak demand you have to look into each hour. So here we are calculating means group demand during each hour. So we are doing sum up. So 50 plus 200 plus 150, that is 400 kilowatt, and this will give you 50 plus 200 plus 150 400 kilowatt respectively. You just do sum of during each time, and then you can see that the maximum group demand is, you can see the table here, it is 400 400 50 550 650 850 1750 1800 2000 2150 1800 1750 2050 1850 1350 1011. So this is, yeah,
2150.
yeah, very nice. So this is the group peak demand. So you have to just take a note down this row. This type of problem is given in assignment but have not covered in the class. I think in the discussion forum we can provide the material. So we have found this system peak. So we have to find the contribution factor for commercial load. So you have to take note down this class demand and type of system peak. So for commercial load, what this value is given 1400 kilowatt. So you have to take this value. We have to nothing related with this group peak demand. You have to take now note down this 1400 kilowatt is the demand during the group peak demand. So numerator will be 1400. So I am calculating the contribution factor for commercial load. So numerator will be 1400, and then class non-incidence maximum demand. So what is the individual maximum demand for that class, for that commercial load? So if you see commercial load maximum demand is, if you see the table, it is coming as 1400 itself. So it is divide 1400 divided by 1400. So you will get contribution factor for commercial load as 1.0. In similar way, you can find the in this problem it is not ask about lightning load and residential load, but we calculate so that we can match the match this relations with this final expression with this be, that expression we know. So this expression we can put all these value and we can take that it is coming or not. So commercial contribution factor for commercial load is coming as 1.00. So D is the correct answer. Now we got the answer, but sake for the sake of clarity and better understanding, we are calculating the contribution factor for lightning load and residential load. So for lightning load, what is the demand during group peak demand? For lightning load, it is 0 kilowatt. So numerator will be 0 kilowatt. And
Zero.
yeah, maximum demand for lightning load, you have to see again the table. For lightning load, yeah, you have to see again table 50, 50, 0 and 50, 100, 150. So 150 is the maximum
One.
demand. So 150 is anywhere it is numerator is 0, so it is 0, 0. So, and so residential contribution factor of residential load. So you have to see the demand during group peak demand. So 750 is the demand during group peak demand, and individual peak demand you have to also see. Individual peak demand for residential is, I think residential is 150, 350 in the night hours only it's given. So 1200 is the individual peak demand for residential load. So you have to divide 750 by 1200 kilowatt, you will get 0.625. And now put all these values contribution factor for each type of load in this expression. That expression relates with group peak demand and individual peak demand. So now we are putting, so LHS is group peak demand, we know that 2150 kilowatt, and RHS is the contribution factor from each load, each type of load, and this individual maximum demand. So you will get same answer. So LHS is RHS, that means you have calculated the incorrect way. And for calculation of contribution factor, I have written down the steps. First step is that you have to find out the time instant at which aggregate peak demand is occurring. So that is set, means if you find the time instant, that's okay. There is nothing relation with the group peak demand. Now for class contribution factor, you have to just put in the numerator whatever the demand occurring during that group peak during that instant divided by the individual peak demand. So that is the contribution factor for that load or for that class, means whatever the demand occurring at the that instant where this aggregate demand is occurring divided by this individual peak demand. So that is in that way you can calculate the contribution factor from the sheet or from the table given. So that's all. Now if you have any doubt you can ask. I will upload this
So,
YouTube video and
so I would like to thanks. Really, it's very truthful and very useful, sir.
yeah, yeah. Thank you, thank you. So who is
Sir,
Sir, please send this PPT also, sir.
yeah, I will share this PPT PDF and this YouTube video link. So you know where
So,
you can get this?
no,
Do
right now you will send the link in a.
no, no, I will say in Swam portal you can get. Like in Swam portal you go.
Okay, okay.
In Swam portal, I will just right now I upload the link for all this. In Swam portal, go to my courses and then like go to course, and here I think it is not up. I think it will upload. Like in the previous session, what happening now? Like those session we completed, there one portal will come. This live tutorial session. So here you will get the link. This is for previous year.
Yes, sir. Yes.
Yeah, so here you will get in the down problem solving session. This will update within 1 or 2 days. In problem
Okay,
solving
okay.
session, you will go here and then you can click here. You will get all this YouTube link and this presentation folder link, backup YouTube video link, and you can see there. So that's all. So on this same time we will meet on the Sunday. Thank you all for joining,
Thank you, sir.
and good night.
Good night.
Good night. Bye bye.